Okay, today guys we are going to be talking about tangent lines and circles. And the first drawing I have here is of a line that is tangent to the circle. And tangent again means that it only touches in one spot. And so we're touching the circle at point P, so that is our point of tangency. The first theorem that I want to discuss is the one that says if you have a tangent line to a circle and a radius that meets it at that point of tangency, then a right angle is created. Okay, so there's a right angle here and obviously on the other side, and you can know that that radius OP is perpendicular to that line AB, that tangent line AB. Those are perpendicular. Okay, that idea is going to come in handy for a problem like this one. This tells us that ML and MN are tangent to circle O, and they want us to find the value of x. So MN and ML being tangent to that circle, and these we have two radius lines or radii drawn in from O to N and L, means that I have a 90-degree angle here and a 90-degree angle here. And you are going to have to remember that if you look at this, the black figure as a quadrilateral, then the angles of a quadrilateral should add up to 360 degrees. So I can make an equation where I have 117 plus 90 plus 90 plus x, and that should equal 360. And then you can easily solve that and get x to be 63. And again, that was made possible because we know right angles are occurring where the radius and the tangent lines are meeting. Okay, here's another example where that thought comes in very handy, that theorem comes in handy. I have a triangle now instead of a quadrilateral. I know that this bottom angle is 38 degrees, and I'm trying to find this angle on the outside. Since I have a line going through O, I know that from O to D is a radius, and it tells us in the given that DE is tangent to that circle. So there's a right angle here, and then I have a triangle, so it has to add up to 180. So I can make an equation, 38 plus 90 plus x is going to equal 180. And again, you can easily solve that and figure out that you need x to be 52 degrees. Okay, here is a third example that this theorem comes into play with. And this can represent any situation where you have gears, maybe on a bicycle, that you have a front rotation and a back rotation that are different sizes. Could happen in a motor, something like that. But let's take this question where these points of tangency are 26.5 inches apart. The radius here is 2.4 inches. The radius back here is 9.3 inches. And our question is going to be, how far is it from the center of one to the center of another? And so I'm going to insert a line to show you what we are talking about. We are wanting to go from the center of this graph, this circle, to the center of this circle. We're wanting to know how far that is. So since that's what my question is, I'm going to call that x. We know that the radius and a tangent line are at right angles, so I know this angle is 90 degrees and this angle is 90 degrees. And this is a quadrilateral, and we don't have anything like the Pythagorean theorem to work it out with. So what you have to do is actually draw in another line, and I'll just freehand this one. Maybe I shouldn't. That goes straight across from one center to the other. So let me stick one in. Much easier. And the goal here is to make a rectangle at the top, because you know things about a rectangle. For example, I know if that's 90 degrees, that's 90 degrees, and that's 90 degrees. If this is 26.5, this is 26.5. If this side is 2.4, this side is 2.4. And so I can find, lots of information now. Since this radius is 9.3 and I've used 2.4 already, I know that this length has to be 6.9. And now if you'll notice, if you put a right angle right here, I've got a right triangle at the bottom, and that follows the Pythagorean theorem. So 26.5 squared plus 6.9 squared will equal x squared. And so if I just multiply these out and add them together, I get 749.86, and I just have to take the square root to get my final answer. Okay, for our last example, we are going to use another theorem about tangent lines, and that is if they come from the same point to the circle in different spots, then they're the same length. So in other words, if I look at point A and it goes to D and is tangent at D, and to E and is tangent at E, these two are going to be the same length. So I could figure out the perimeter of this entire triangle just using that knowledge, because if this side is 8, this side is also 8. You have the similar situation at B, because B to E is a tangent line and B to F is a tangent line. And so if BE is 10, BF also has to be 10. And then finally with C. C is tangent, or the line from C to F is tangent at F, and the one from C to D is tangent at D. And so if this is 15, this side is 15, and all you would have to do to get the perimeter would be to add 2 8s, 2 10s, and 2 15s to get you a perimeter of 66 centimeters.